Hello everyone, I am Margin de la Cruz of SIP 1 of the reporter on your journey on Chapter 10, Utilization of Data Assessment. So this is our overview. In this chapter, we will get to know the test results of the student's performance that can aid in making informed decisions in order to improve curriculum and instructions of the teacher. We shall look to the different types of test scores and interpret it as well. This chapter will also present test scores interpretation using norm criterion reference interpretations. Here are the intended learning outcome as we continue in our topic. At the end of this chapter, students are expected to provide meaning to test results using norm reference and criterion reference interpretation. So now, let's proceed to the types of test scores. Here are the types of test scores. Pro and percentage scores, percentile ranks, standard scores, and associated with standard scores, Z-scores, T-scores, stand-ines, learning curve equivalent, developmental scores. So, according to Harris 2003, results of tests are in the form of scores, and this may be raw scores, percentile, ranks, Z-scores, T-scores, stand-ines, or level category or proficiency scores. So, what is raw scores and how can we determine raw scores? So raw scores are obtained by simply counting the number of correct responses in a test following the scoring directions. So for example, if there are 50 items in a math test and student get 30 correct responses in a test, the raw score is 30 over 50. Again, as you can see in the screen, the correct responses of the student in the math test is 30 over 50 that serves as a raw scores. Again, raw scores are obtained by simply counting the number of correct responses in a test and following the scoring directions. So, in the other hand, how do we get its percentage scores? So, to get that, we just have to divide the correct responses over the number of items in a test. So if the student gets 30 correct responses out of 50, so 30 divided by with the number of items, which is the 50, is equals to 0.6. And multiply it by 100. So the equal will be 60%. The percentage score is 60%. As a result, the student was able to answer 60% of the items. Let's move on to the percentile ranks. A percentile rank gives the percent of scores that are at or below a raw or standard score. It is used to rank students in reference sample. So note that percentage score and percentile rank is different from each other. In percentile rank, we can determine the rank of the student based on his or her score and compare the rank to other students who also take the test. For example, if the student gets 35 and 35 is equivalent to 84 percentile, let's say there are 200 students who also took the test. So, how can we get the rank? Here are the solutions. 84 divided by 100 is equal to 0.84 times 200, which is the number of students who also took the exam. So, the percentile rank is 168. If there were 200 students who took the test, a percentile rank of 84 indicates that the student is higher than 168 students. So next is standard scores. Standard scores. It is difficult to use raw scores when making comparison between groups on different tests, considering that tests may have different levels of difficulty. For example, a test of a math and science subject. Do you agree that these two subjects have different levels of difficulty? Yes, it is. If the student gets 40 over 50 in the science subject, while in mathematics the students get 25 over 50, we can't compare these raw scores because the two different subjects have different levels of difficulty. How can we determine and make comparisons of these scores? We can determine it by using derived scores. What is derived scores? It is a family of scores that allows us to make comparison between test scores. There are two types of derived scores: scores of relative standing, developmental scores. So scores of relative standing, it includes percentiles, standard scores, and standines. While the other, which is the developmental scores, are scores that have been transformed from raw scores and reflect the average performance at the age and grade levels. So, what do you mean standard scores? A standard course is the name given to a group or category of scores. Each specific type of standard scores within the group has the same mean and the same standard deviation. So here are the different types of scores of relative standing: z-scores, t-scores, and standine. So this is the image of normal distribution standard deviation. Here we have our mean, which is 0 in the middle. In the right side, we can see the positive value, while on the left side, we can see the negative value. We can also see the cumulative percentages: percentiles, z-scores, t-scores, and standard 9, which is the standine, and lastly, the percentage in standine. So let's start our discussion in z-scores. The z-scores gives the number of standard deviation of a test scores above or below the mean. Here are the illustrations of z-scores. Z equals to our raw score minus the mean and divided by to our standard deviation. So here we have an example of a normal curve. The mean here, which is 0, that is located in the middle. Negative z-score is below the average, while positive z-value is above the average. If we got a z-score below the mean, it is negative. The same way with the other side, if we got a z-score above the mean, it is positive. So let's dive in the algorithm step for z-score. Step 1. Subtract the x raw score or test scores to the mean. Step 2. Divide the total score to standard deviation, which is ds. So these are the examples of z-score. A score of 12 in a 20-item science test with a arithmetic average of 15 and standard deviation of 2. So the given is our raw score, which is x, is 12, our mean is 15, while our standard deviation is 2. So we're going to use a formula of z-score. 12, which is the raw score, minus to 15, which is our mean, equals to negative 3, and we will divide it to our standard deviation, which is 2 equals to negative 1.5. So, let's proceed to t-score. In a t-score scale, the mean is set to 50 instead of 0, and the standard deviation is 10. To transform a z-score to a t-score, we multiply the z-scores by 10 and add 50. So, below is the formula of t-score. T equals z times standard deviation, which is 10, plus the mean, which is 50. So earlier, we've been discussing about the z-score. We're gonna use the z-score to get the t-score. I'm gonna show you the formula below. So we're gonna use our z-score to our t-score. So t equals 10 and multiplied to our negative 1.5 z-score that we've been solved earlier plus 50. So t equals negative 15 plus 50 and t equals to 35. So t-score of 35 indicates that the row score of 12 is 1.5 standard deviation below the mean. This implies that based on the test scores, the student performed below the average. So let's dive into step 9. According to Marin and Lehman, 1985, a student with a standing score of 2 may have a percentile score anywhere from the 4th to the 10th. To show significant difference between two scores, there should be at least one standing score between them. So, what is Stan 9? A Stan 9, a short for Standard 9. It is a method of scaling score on a 9-point scale. So, Stan 9 is a 9-point grading scale ranging from 1 to 9. Unlike z-score and t-score, the mean of Stan 9 is 5 and the standard deviation is 2. So below is the formula of Stan 9. So, I have here a normal curve of Stan 9. So these are the scale of Stan 9. So 1 to 3 is below the average, 4 to 6 average, and 7 to 9 is above average. So the next further will discuss the remaining topics.